And the second case study I will talk about, it's a G protein coupled receptor implicated in inflammation resolution. And in this case, actually, our client had already a lead candidate that worked very nicely as showing phenotypical effect in vivo or on cells, but it was very difficult for them to show any target engagement or any in vitro binding directly between the protein of interest, the target, and the antibody of interest. So we said, okay, maybe the problem is that this protein is not in its right conformation and environment. Let's try several and see what we get. So again, we did all these steps, expression, purification in specific mixes and environments. We went and did a G-validation assay with benchmark and with the candidate. And in this case, we also did some cross-species interaction for the in vivo studies and for One Health as well. So first of all, it was well expressed, purified mainly as a monomer. What we did from there is we took this receptor that was very nicely purified and put it in different environments, including macrophage, liver, and kidney, and some simple mixes like POPC-CHS. And we went and did some ELISA, some dose response ELISA, using either the candidate or a negative control antibody. And so what you see here is actually the result of an ELISA coming from the same exact antibody used all the time on the same exact target, but in different environment and in different formats and in different conformation, most probably. So the negative control are the black curves here, so it's quite negative. But what was really striking is that dependent on in what you used your protein, your target, the result of the dose response was very different in terms of IC50, but also in terms of Bmax, of maximum response. So we choose the one that had the best answer, of course, with the SP3L10, and we went and did some G-validation assay to see what does this antibody do. And for that, we compared with 3 ligands. Those are the natural ligands of the receptor in the human body. Those are all agonists. And we could nicely see some activation profile with all the ligands, ligand 1, 2, and 3, but also with MAB1. So the one that we were testing, we saw a very nice activation profile, but not with MAB2, which was also a binder, but didn't show any effect when added to the protein. So what we could demonstrate is that MAB1 provokes a dose response activation that is similar to the benchmark ligands. But we went a bit further and we said, okay, let's see if this antibody can be a competitor. And so what we did, we used first the internal ligand, the natural ligand, to activate the receptor, and then added either MAB1 or MAB2. And what was really surprising is that we saw an overactivation when we added the MAB1 on the ligand 2, while when we added the MAB2, nothing happened at all. And so this is a hint that MAB1 is a positive allosteric modulator in the presence of the endogenous ligand 2, which is really interesting and important for the future development of the candidate, because we need to know what kind of profile and what kind of mechanism of action this antibody is able to do. We also did, as I mentioned, some cross-species comparison, and we could clearly see that target from mouse and from monkey are able to activate similarly this antibody to the human target. And also we did the same with the dog target. And this was really interesting because in this case, we know that we can use the same antibody as a medicine for human, of course, but also for dogs.